Hello, you're watching Everard Junction, and today is the big one. This is the video that numerous viewers have requested and asked me to do over the last 12 months. This video is probably going to be quite a long one, probably the longest video I've ever done. I've done a hell of a lot of editing and I've reshot some of it 3 times. There's been a lot of effort going on in the background to edit it down and get it all to flow nicely, so hopefully the video will be enjoyable for you. The project is quite difficult. It's not an easy project. Here's a picture of the circuit diagram. This is the sort of thing that I'm going to show you how to do. There's also a computer program that is associated with this, so that chip in the middle of the circuit diagram, you'll write a very simple program that will be running to automate the process. So yeah, it's going to be quite involved, but I've done my best to explain it, done a lot of editing, done a lot of filming. Hopefully you'll enjoy it. Before we get started, I'm just going to very quickly just go through roughly what the signal does. So at the moment you see this gantry here has 2 signal heads installed on it. The one on the left is 3 aspect, the one on the right is 2 aspect. The explanation for the video will be mostly on a 4 aspect, as that is the most complex, but I can show you here that first of all I have a switch, so I can override the signals and I can set them to danger. So when they're on green, they're on their sort of default position and the circuitry takes over for detecting trains, and when they're set to red, they always stay on red unless I flick the switch back. So it's quite useful in certain places, particularly here where I've got one line that goes into 2. There's an infrared sensor in the track, and when the train passes over that sensor, it trips the signal into red, and now the circuitry and timing sequence will take over, and it'll work its way to yellow, and then if it was a 4 aspect signal, double yellow, and then back to green. So you can see now after that train has passed, signal's gone to yellow. There's a 30-second delay I've got it set up for at the moment, so in another 30 seconds it'll switch back to green. So you can see the signal's now gone back to green. It's now ready to be triggered by another train. The signal will trigger itself automatically if it sees a train when it's showing yellow or green, just like the real things do. And I can also override it, as mentioned previously, back to red if I want to lock the signal down and mark the line as permanent danger while I do some shunting or use another line. So that's a brief overview of how the signal works, so let's not waste any more time. Let's get straight into how to do it, and we'll start off by taking a look at all of the stuff you're going to need. Okay, so I'm going to just very quickly run through everything that you need to get this project complete. I'll go through it relatively quickly, but don't worry, the video is quite long, and as we work our way through the video you will see all of this stuff in greater detail. Links in the description for places to get hold of it. I'll try and put everything in there, but if I have missed something, or if you do need to know where to get something and you can't find it for whatever reason, drop me a comment and I'll do my best to try and get back to you. Okay, so the first thing you'll need obviously is a soldering iron and the ability to solder, which is also quite useful. You'll need solder obviously, and I would recommend the use of flux where possible, just makes things that much easier. Moving along, we've got resistors. I use various values, and their values and numbers and positions and what have you will become much clearer as we work our way through the video. Over here we have breadboard. You've seen me use this before. This is what allows the electronic components to be soldered in a more permanent state. You buy this stuff in sheets and then you cut it to size. I use a Dremel to cut it to size with a cutting disc. It's quite brittle and it doesn't like saws or scissors. It tends to shatter quite easily or break. The thing that I've soldered to the top of it is the little docking station. Lets you plug the chips into the circuit without the need for soldering. Moving over here we have the infrared sensing part of the circuit that detects the presence of trains. We have the infrared emitters and receivers in there, and we'll come on to those in more detail as we progress. Moving down here we have the Pickaxe programming device. You plug this into your computer with a USB cable, and it allows you to download any programs that you have written in the Pickaxe software onto the chips. So that's how you get the program onto the chip. Here we have some simple on-off switches. Their use will become apparent as we progress through the video. A multimeter is also extremely useful for troubleshooting the circuit if you have any problems, and for also furthering your understanding and actually getting a handle on sort of how all of this stuff works. We move across, obviously signals, they're very important. That's the whole reason you're doing this project. Lots of people make signals. For the purposes of this video, I'll be using the signals I have already prepared onto these gantries, which you saw in a previous video. Moving on, we've got some wire strippers, very useful for cutting the wires and stripping the ends of them. Obviously the wire itself you will also need. A scalpel may also be of use to you. And one of the other major things that you will need is a breadboard. These are available from various people. I got this particular one from Maplin, but you can also get them from Rapid Electronics. Again, links are in the description for as much of this stuff as possible to aid you in obtaining it. This is really useful because it allows you to loosely assemble a circuit and test out various things, and it's also very useful for furthering your understanding in how something like this works. Basically what I do is I assemble the circuit, as you see here, on a breadboard, and then I can test that what I've actually come up with works, and then once I know that this works I can then commit to actually soldering it all together in a more permanent basis. You will also need to get your hands on a computer and install the Pickaxe programming software on there. I use the Pickaxe Logicator for writing the program. We'll come onto it in far greater detail later on, but that's what it looks like, and we'll come onto that, as I say, in more detail later on in the video. The last thing you will need, which you may already have, is some sort of power to run the circuits and the associated signals. Now, most layouts tend to have like a 12-volt accessory power bus. Indeed, on the back of a lot of controllers, there will be a 12-volt accessory output. These circuits are slightly different. They run off 5 volts, and they're very fussy about that. You will cause damage to them if you run them on any more. As you can see, I have a nice little power supply here, which has a variety of outputs on it, and one of those outputs includes 5 volts. So up on the layout, what I have is I have a separate set of bus wires that are dedicated for just running the signals. You can also use a ATX PC power supply, repurposed from an old computer. I'm sure you've got some old computer somewhere. The power supplies in those computers, you can pull them out and repurpose them. It does require a bit of work. It's not just a plug and play deal. Plenty of YouTube videos and Google instructions on how to do that. But I just wanted to give you the option. It is possible to use the power supply from a PC for layout accessory power. I'll be using this power supply during this video, as it is what I use to power the signals on the layout. Okay, so now we've been through the basic components, I shall get started. Okay, so I have loosely assembled the 4-aspect signalling circuit on the breadboard here, so that I can check that it works. I'd recommend you do this when you're starting out in the project. Troubleshooting and working stuff out and taking readings with a multimeter and messing around and adding things and removing things is a hell of a lot easier with something like this. So this is what the circuit looks like in 4-aspect form. There's the diagram again. So that circuit on that diagram is what you see here in front of you on the breadboard. I've tried to lay it out as close to the circuit diagram as I can, but you will find when you do stuff like this that you can never copy it exactly. But it is a good idea to try and make the circuit look as much like the diagram as possible, because it aids troubleshooting and even further makes understanding what's going on easier. Now, this looks a little bit complicated straight away when you look at it as a whole, but it can be easily broken down into 4 key areas. So the first area is here, and this is the sensor. This is what detects the presence of a passing train. This is the infrared detection circuit, and you can see, just like on the circuit diagram, it's laid out in a square. You can see here, this is the infrared LED. To the naked eye you can't see this, but the camera does pick it up, which is quite useful for the aid of this video. And then here we have the sensor, or the phototransistor. The next area of the circuit is the Pickaxe chip, the microcontroller, which contains the electronic program that's running all of this. which we'll come on to later on. And you can see that to get it powered, I've got the red wire going up here to 5 volts, and then I've also got a white wire going down to the bottom, which is the earth. So the chip is powered, and that'll be running through its program as we speak. The next spot is the 4 outputs, which can be easily represented by these 4 resistors. So the signal has 4 LEDs because it's a 4-aspect signal. So I have 4 220 ohm resistors, and then you can see we have the cables there, the 4 cables which go off into the signal itself. And the final area is here. This is the switch, the manual override switch that will set the signal to danger for the purposes of filming or special movements on the track. I haven't actually wired a switch directly in, I'm just representing it with this piece of red wire. So when I pull the piece of red wire out, it will switch over to red, and I have this resistor here going down from this wire to earth, which anchors it at 0 volts when this is disconnected. So to begin with, it looks quite complicated, but if you break it down into the 4 spots, it does make things easier. So you have the sensor, the chip, the outputs, and the switch. So for the purposes of demonstrating, I have just temporarily wired in one of my signal gantries with a 4-aspect signal head in there. Now if I was to take a reflective surface, such as this piece of kitchen foil, we should be able to represent a passing train. So if you imagine the sensor and the LED are embedded in the sleepers in the track, when the train passes over, what I usually do is I put a little piece of foil on the bottom of the locomotive just to make things doubly sure that they're going to work. When it passes over, the light that's currently coming out of the LED and going sort of over in this direction, that'll be bounced off the tin foil and it'll go into our receiver there, and that should give us an electrical signal. So if we move over to the signal head, and I get my piece of tin foil, if I move it close enough, there you go. Can take a second or two sometimes, and also this piece of foil is very scrunched up, so its reflective properties are not brilliant, but you can see that by doing that, by pretending that I was a passing train, I have switched the signal over to red. And now with the signal at red, the grand scheme of things is taken over by the chip, and the program has started, so it's now running through its cycle. So you can see it's already changed to yellow. I leave 30 seconds for each aspect, but you can adjust that to anything you like. Okay, so that's gone round through its cycle, and I'll just quickly show you the switch. So I'll just this piece of wire just represents the switch. So if I open the circuit on the switch side, it trips it into the override, and no matter what happens, that will stay red until I reconnect the wire or close the switch. So if I go to plug the switch in, you can see it goes back to green. That's just a handy little feature. You don't have to put it in the circuit, but I find it quite useful. I thought I'd just quickly show you the sensor, the sensing circuit, and how it works. So there you can see the circuit laid out like it is on the diagram. And if we look at the diagram, we can see that it is connected to pin 1 of the microcontroller, which is the top right-hand pin you see there. So I've just got a multimeter on it at the moment, and you can see that we are currently getting a signal of 4.5 volts. There's 5 volts available, and some of it is going to the right, going this way to illuminate the infrared LED. The rest of it is headed this way to the sensor, but at the moment the sensor isn't picking up anything, so it's being diverted into the chip. So we're currently getting a signal of 4.5 volts. So as far as the chip and the circuit is concerned, it can't see anything, and there are no trains passing. So if I take my piece of tin foil again, you don't have to use tin foil, you can use anything that's reflective, but this does the job quite nicely. So if I place this over the top, now the light coming from the infrared LED is being bounced into the sensor, and the sensor is picking up, and we can see that the voltage has dropped considerably, and it will vary depending on where I move the foil and how far away I move it from the sensor. But if you can imagine the sensor and the LED sitting in the rails, when the train passes it's extremely close to it, so you're going to see very low amount of voltage. And then once we remove it, it goes back up to where it was, and now as far as the circuit is concerned the train has passed, it's no longer there, and it will run through the sequence. So you can see we're already changed onto a yellow aspect. And then obviously at a yellow or a double yellow, a train is permitted to pass. So let's use the foil again, represent the train passing. See the voltage dipped right down again, and we've now reset back to a red aspect, and the circuit will continue to do that all day long for as long as you like. Okay, so that's the circuit diagram, and that is how the circuit looks like when it's loosely assembled. And as you've just seen, we have verified that it is working as intended. So from this point I would then move on to soldering it all together for real and putting the project together. But obviously you guys need to see the program and how that is written, and that's going to be probably the most complicated bit, so I'll try and keep it simple, but we'll see how we go. Okay, so here we are at the computer, and I'm going to show you how the program is put together and how we get things going. So I use the Pickaxe Logicator software. It's probably the first time most of you have seen this. It's not too bad to understand this. You can get your head around it fairly easily, but this is your first time you've probably seen it. So it's going to take a fair bit of explanation. I'm going to try my best. I'm not a teacher, but I'm going to do my best to teach you how to use this software, at least from a basic level. So one of the first things I like to do is show the digital panel up here on the top left hand side, and this shows me a little explanation for what the various pins are numbered on my 18M2, and that's very useful for just referencing. So I'll be using a combination of the program here and the digital panel and the circuit diagram, which I'll be using for reference, and hopefully that'll make things easier to understand. So basically what we have here is the program for a 4-aspect signal. The program is fairly similar for various aspects of signal. You just need to change a few things down here in the larger program. So this is the 4-aspect signal, so this is the most stuff you're going to have. 3-aspect signal, you wouldn't need this or this or this. And for a 2-aspect signal, again, you would need even less. You just need red and green. So I'll start at the beginning, and we'll work our way through what is going on. So if we come up to the start of the program basically follows a route, which is defined by these arrows here. So at the start, it'll come down to this area here, and then it just follows these arrows, so you can see where it's coming back. It comes back up to the start, so the whole thing sort of goes round in a loop. So here's the beginning of the program, and you can use these little tabs here. You can just drag these over from the right hand side, and you can put them in. And then you can right click and you can draw a line to go there. So that would be start program, and then move down to here, and then in here what you can do is get rid of the line, go in here, and then you can set an output pin, let's say pin 3, turn it on. And that basically all that does is start a program and turn something on. That's all it does. So that, in a very loose sense, is what you do. You just basically use these things on the right hand side to do stuff. So the first thing that happens when the program kicks off is it asks a question. That's this decision tab on the right hand side. So you can drag one of these out, and then you can double click it, and you can decide what your question is going to be. So let's get rid of that. Go back to my question. So you have a no and a yes, and then depending on the answer will dictate which way the program goes. So yes, we go to the right, no, we go down to the bottom. If we double click on it, we can see that the decision is pin 2 switched on, or is it high? That's what the question is asking. Is pin 2 high? Okay, well let's have a look at the digital panel, and let's have a look at pin 2. So here's our digital panel. Pin 2 is the top one on the left hand side. If we have a look at the circuit diagram, there's P2, top on the left. If we follow the wire, we can see this is the switch, this is the override switch. So the first thing that the circuit is doing is it's saying, okay, right, we've started. Has the override switch been turned on? Now, depending on the answer it gets to that will dictate which way it goes. These question tabs, by the way, you can also swap round the yes and the no to get the program a little bit easier to understand and lay out. At the moment I've got it set the wrong way around, so let's change that. So at the moment it will say, has somebody turned on the override switch? If it says yes, we come down here and it says put the output Q0, if we double click it, put the output Q0 to high, or turn it on. Okay, let's have a look on the digital panel and find Q0. The outputs are always down the bottom, so here's Q0, it's the fourth one up on the left hand side. Let's have a look at the diagram. Fourth one up on the left hand side, Q0, we can see is the red aspect of the signal. So the first part of the program says, okay, start. Has somebody turned on the override switch? Yes, they have. Okay, set the signal to red. As long as the override switch remains pressed, it's going to keep going round and round and round and round and round. Now, under normal circumstances, the override switch will not be pressed. It'll be turned off and the signal will be operating in its normal fashion. Okay, so let's have a look at the question again. Has the override switch been pressed? Basically, has pin 2 been switched on? Usually the answer will be no. So we come over here and instead of output Q0, we have output Q2. Let's double click it. We can see that Q2 is set to be switched on. Let's have a look at the digital panel and find 2. There it is down the bottom. It's the second one up on the left hand side. So if we go to our circuit diagram, we can see that that is the green aspect of the signal. So under normal circumstances, when you haven't pressed the switch, it'll go start. Has the override switch been pressed? No, it hasn't. Put the signal green. Once it's put the signal green, it'll ask another question. And this question is, has pin 1 tripped low? Now pin 1, if we have a look on the digital panel, is the top one on the right hand side. So let's have a look at the circuit diagram again. There's pin 1 and we can see that it's linked up to the infrared sensing circuit, so the part of the circuit that searches and detects for trains. So what it's saying is, okay, the signal is currently showing green. Is a train coming? Has it passed the infrared sensor? Under normal circumstances where not much is happening on the layout or the railway, the answer to that question is going to be no. Because if you remember when we looked at the multimeter, when the sensor gets a signal, or when it sees infrared light, and it sees something passing overhead, what it actually does, remember on the multimeter, is it dips low. The voltage reduces down to almost nothing in certain cases if the reflective surface is close enough and if the LEDs are positioned rightly. So it's going to say is pin 1 low, and under normal circumstances no it isn't, it will be high. So the answer to that question will be no. Pin 1 hasn't dipped low, it's currently high at the moment because it's just sitting there, it hasn't seen anything. So it will follow the arrows and it will go back round to the start. So when this override switch is not pressed and when no trains are passing, it just goes around in a loop, constantly making sure the signal is showing green. Now when a train does pass, it is going to send pin 1 low. Again, remember back to the multimeter, when the sensor picks up something, the voltage dips right down. So let's say a train has passed, we've got a yes to that question. First thing it does is it comes down here and it says set the output Q0, if we double click it, output Q0 to be switched on. Now this is an output tab and it's exactly the same as the one over there. So what's that going to do? It's going to switch the signal to red. It's Q0, remember? Come back over to the diagram, there's Q0, it's the red. So first thing it does, as soon as the train passes, signal goes red. The next thing it does is it goes to this wait tab. This is how I get the signals to stay at certain aspects for a certain period of time. So it's currently set to wait for 30 seconds after the signal has been switched to red. And you can adjust this up to 65 seconds And if you need any more than 65 seconds, then what you can do is you can just put another one of these wait tabs underneath, and it will continue delaying itself as it works its way down. So once it's waited for 30 seconds, remember this is a 4-aspect signal as well, next thing it's going to do is go output Q1. It's going to switch Q1 on. Okay, let's have a look at the digital panel. Q1 is the third one up on the left hand side. Third one up on the left hand side is the first of the yellow aspects. That's the single yellow. As soon as it's done that, again we wait for 30 seconds. After that 30 seconds has passed, it asks a question. This question is, has pin 0 been switched on? Okay, let's have a look at the circuit diagram and see what's going on. Here's pin 0. It's the second one down on the right hand side, and you can see it's linked up to the red aspect. So when red is showing, pin 0 is going to be switched on. Now the only reason pin 0, or the signal, would have been switched to red is if this program on the right hand side had stepped in. Now I'm going to assume for the moment that that hasn't happened. We'll come on to this in a moment. But what this basically does is it has the ability to override this program if the train passes the signal when it's showing yellow. So if we go back to the main program, it set the signal to yellow and it waited for 30 seconds. It then asked if it had been overridden and set back to red. Let's assume it hasn't for the moment, just one train passed. So the answer to that question will be no. The next thing it'll do, because it's a 4-aspect signal, is going to set the outputs Q1 and Q3 to be switched on. You can see them there. Let's have a look at the digital panel. Q3 is all the way at the bottom on the left hand side, and Q1 is the third one up. If we look Q1 to Q3, it's going to set the signal, because it's a 4-aspect signal, to show double yellow. So that makes sense. Then again, I'm going to wait 30 seconds, and at the end of the 30 seconds it's going to ask the same question again that it asked up here. That question is, has the signal been set to red automatically while I've been doing these delay processes? Again, let's assume it hasn't for the moment. So it will get a no to that question, and then it will come all the way back and it will go around to the beginning, and the signal will go green. And it will go green provided that the reset, provided the override switch hadn't been thrown. So as long as you hadn't messed around with the override switch, once it finished and got down to here, it'll just set the signal back to green again. And then the signal will stay green until the sensor detects another train coming, and the pickaxe chip sees that pin 1 has dipped low. So it'll just keep going around and around and around until pin 1 dips low and another train is spotted, and then it just goes back through the same process again. So that, in a nutshell, is how this program works. This is the main program that operates the majority of the signal's functions. Okay, so that's how that main program on the left hand side works. Let's just quickly look at the much smaller program on the right. Now the sole reason this program exists is so it has the ability to set the signal to red if a train goes past when it's showing yellow. This program only has the ability to ask if a train has been seen up here at this question, this decision tab. Once it has passed this point and it's down here in one of the yellow conditions, it's either waiting 30 seconds after the signal has been set to single yellow, or it's waiting 30 seconds after the signal has been set to double yellow. When it's down here, it can't see trains. It doesn't have the ability to be in two places at once. It can't be down here waiting 30 seconds and also be up here asking this question. So that's what this program's for. This program starts off, and the first thing it does is it says, has pin 7 been switched high? Okay, let's have a look on the diagram. Digital panel shows that pin 7 is the third one down on the right. So we have a look on the diagram. It goes down and it's connected to the yellow aspect of the signal. So when we switch the signal to yellow, which is what this program will do, this program will pick up that the signal's now at yellow, so it needs to look for trains because this program's not going to be able to. So the next question it asks, once it's got a yes to that question, so it says, has the signal gone yellow? Yes, it has. So it goes down to this question. This question is the same one that this circuit asks, and it says has pin 1 dipped low. Pin 1 is the top one on the right hand side, and it's connected to our sensor. So it says, okay, the signal's gone yellow, has the sensor tripped and seen anything? If it gets an answer of yes, so let's say a train shoots past when the signal is showing yellow, this will go, yes, I've seen a train just passed or is in the process of passing. What I'll do is I'll set the output to Q0. You can see Q0 be switched on there. Come down to the picture diagram. Q0 is red. So it'll say, has the signal gone yellow? Yes, it has. Okay. Has a train passed? Yes, it has. Okay, set the signal to red and go back to the beginning. Once it goes back to the beginning and switches the signal onto red, the yellow will go out, so it'll get an answer of no to the first question, and it'll just loop round waiting for the signal to go back to yellow before it needs to step in again. That's where this question comes in over on the main program. So this one's just, for example, set the signal back to red. This program does not have the ability to know that that has happened. So once it's finished waiting 30 seconds for either of the yellow parts of the signal, it's going to go, okay, has the signal been set to red while I've been down here and doing this waiting business? If it gets an answer of yes, what it does is it goes back up to the beginning and it goes, okay, well also I will go back to red, and I will then wait 30 seconds. That should give you ample time for that train to pass, and then it can then set the signal back to yellow. And then again the process can repeat. So by the time the signal's gone back to yellow, if the train comes round again, this program on the right hand side will step in, switch it back to red. By the time this gets down to this question, it'll go back to red. If the trains stop coming, then it'll get all the way to the bottom, it'll get a no, and it'll go right back to the beginning and set it to green. So hopefully that makes sense. That's how the two programs work, and I hope that was helpful. You may need to pause it or watch it once or twice, but it should make sense, hopefully anyway. If you wanted to set the program up so it was running a free aspect signal, I'll just quickly show you. Get rid of that, get rid of that, get rid of that. There we go. Now if I start a line, go up there, get rid of that. That is a free aspect signal. So all I've done is I've removed the bit where it sets the double yellow, because it doesn't exist in a free aspect signal. So it'll go red, wait 30 seconds, yellow, wait 30 seconds, check if it's been set to red. If no, go back to the beginning, and then it will go green. And then for a two aspect signal, you don't even need that. You just can get rid of this, get rid of this. You can still keep the program here if you want. It won't have any effect on a two aspect signal because there's no yellow. You've just got red and green. So let's say it's a platform starter signal or something, so you could get rid of this completely if you wanted to, and then just start the line. Don't need that either. Start the line, and you can see a two aspect signal really is very simple. It starts off and it says, has the override switch been engaged? No, it hasn't. Okay, show green. Has a train come? Yes, it has. Okay, show red, wait 30 seconds, then go back to green. So a two aspect signal really is very simple, but for the purposes of this video I've been showing you a four aspect one because that is the most complicated. Okay, so now we've been through the programming. Just quickly show you how to program the chip. It really is very simple. Now the program I explained to you was a four aspect signal, as you saw. I'm actually going to be wiring up a free aspect signal because I've already made various boards for four aspect signals. I don't actually need any more at the moment. But the program is pretty much the same. The only thing it doesn't have is the outputs Q1 and Q3 for making the signal go double yellow. Other than that, the program is exactly the same. So it's actually a little bit easier to write. So on the little programming board, you just pop in the chip. It goes in fairly easily. You will need to probably prise it out with a screwdriver when you're finished. Connect up the battery pack, and then plug in the USB cable into your machine, and then it really is just a case of going up to pick up at the top, and then just going program pick, and it'll tell you how far it's going and what it's doing. Once it's finished, the window just disappears, and you are now safe to disconnect the battery pack and unplug everything and put the chip into the circuit. Okay, so it's time to solder the circuit together onto the strip board and do everything for real. So there we are, soldered together. It does take quite a while to solder it together, but you just need to be patient and try not to get too annoyed with all of the wires that are going on. So hopefully that gave you a rough idea anyway of the sort of stuff that's involved in soldering it all together. So just very quickly I'll just highlight the main areas. So over here we have the power coming from our power supply, so 5 volts coming in there. You can see that it's sent to the both sides of the chip. Here, these 2 wires that go along here, those are the ones that are necessary for that little program to detect trains when it's showing yellow. Over here we've got the 2 wires and the resistor for the override switch. Got the 3 outputs there for the LEDs themselves, the signal head. If it was a 4-aspect signal, I'd just have another resistor down there in that 4th row. This 10k resistor here is the earth for the chip. For some reason these chips you always need to put a 10k resistor into pin 3 in order for them to work. This black wire just here is an earth for the outputs, the signal itself. So these 3 send power to the signal's LEDs, and then this is the return. It's the earth coming back from the signal. And then this red wire, this blue wire, and that blue wire, which is also an earth, they go down into the signal's sensor. So that's the infrared sensor. So that's pretty much all of the areas. So I'll just show you a few last things you need to do, and then we can put it on the layout. So before you can put the chip actually in the circuit and get things up and running, what you need to do is you need to basically cut a line through the layer of copper on the circuit board down here, because you can see this is where the chip is soldered in, and obviously each side is its own separate input or output, and at the moment they're basically joined together, so you're going to have a short circuit. So what you'll need to do is just cut down there just to keep the 2 sides of the chip separated, otherwise the whole thing will just short out and it'll never work. I personally use a Dremel with a cutting disc to do this job, as it only takes a few seconds. So there you can see, cut the line. I'll just use a brush to get rid of the dust. But oh, actually, see, I've just missed the bottom one actually, so I'll just do that. That's better. So that will stop the circuit from short circuiting. There's a better look for you. It's the sort of thing you need to achieve. Just need to break the conductive copper contacts on the top, and then once you're into the material itself, you don't need to cut through that. Just need to get rid of the top layer. I've wired everything together, and we are now ready to test the board that I have just soldered up. The chip is programmed and it's ready to go. It's in there. So let's see if it works. I've tried to lay everything out again in a way that's easy to understand. So here we have our power. Comes along, goes into the chip. We also have these wires for the infrared sensing circuit. I've also got my piece of foil to represent a passing train. If you imagine, these are embedded in the track, in the baseboard, sticking up like that. So that's how they will be. We've also got the override switch to set it to red, and then finally we have the outputs that go to the signal. Now on the layout I will solder these 2 together, but as we're just in the testing phase at the moment, I'm just utilising the breadboard to do that. So I've just got one of my gantries plugged into the breadboard. Okay, so when I flick the switch, if I've soldered it together correctly and we haven't got any short circuits, we should get a green aspect. And thank goodness we do. Excellent. So I've just dimmed the light so you can see the signal a bit easier. So this will be the final test I do before I put this all up on the layout. First thing I'll quickly check is my override switch. When I flick it, we should go to red. And we do. If I flick it back, go back to green. So that's good. First part is working. Next part is the infrared sensor. Again, the camera very handily picks up the infrared light, so you can see the infrared LED there emitting, and the receiver is ready to receive the reflected light. So if I wave my piece of foil over the top, you see it goes to red. I'll start a timer. It should take 30 seconds before we get to the yellow aspect. There we go, gone to yellow. Bear in mind I did start the timer a little late, so that's working properly. Should be another 30 seconds to green. There we go, we're back to green, we're back to the beginning. So that proves that the infrared sensor is working, proves that the override switch is working, and it proves that the signal is working. So now I'll do the final test, and that will be to represent a train passing the signal when the signal is showing yellow. When it passes at yellow, it should go back to red, and if it passes that test, this circuit board is ready to go onto the layout. So there we go, we are showing yellow. So this is the final test. Here comes the train. Straight back to red. Perfect. It is all working as it should be. Okay, so some time has passed and I have successfully installed the signals and the associated gantry in the final position on the layout. Basically, I drilled quite a large hole in this area so I could get the gantry glued in and route the wiring for the signal heads down into the baseboard, and the sensors are installed directly underneath the signal. I tend to put the sensors directly underneath, or I'll put them slightly further ahead to give me that sort of prototypical delay that you certainly used to see in the 1980s, where the train would pass the signal and it would actually be a few seconds before it would trip, and in some cases it could be quite extreme. Both of the override switches are still working nicely, so I can flip the signals between red and green manually. And that's particularly useful on this area because, as you can see, I have two lines that ultimately end up into a single line, so it wouldn't be realistic for both of these signals to be on green. I would need one of them to at least be on red. So let's say, for example, that I've got a train running around the layout on this track here, and I've got one sat in the platform here, then I would need to flip the 2 aspect onto red. And likewise, if I had the passenger train in the platform running around and I had a freight or something parked in that centre track, I would flip it over the other way. So it's nice to be able to have that manual control, and you can also set both of them if you need to. So say I was operating trains in and out of the yard, I can set both to danger. To ensure this always works, I fit some foil underneath the locomotives. I've done this with all locos on the layout, or at least I'm trying to. There are a couple that haven't got this installed yet. On the larger diesels, as you can see, I put the foil underneath the fuel tanks. It's a nice flat surface. On the DMUs, I tend to put the foil underneath the bogies. You need a tiny amount of foil. You really don't need very much at all. The slightest bit of reflection, once those sensors are in their final position, will trip them into setting the signal red. Here's a better look around the whole sort of thing. To glue the gantry, and I basically balanced lots of stuff either side and underneath it to get the pitch and the angle right, so it is sitting in a nice final position. The sensors, as you can see, are installed directly underneath. You can't see the infrared light being emitted from those LEDs, but the camera does pick it up, so it's very useful for you guys watching now to be able to see where they are. But to the naked eye, I can't see a thing. One final word of advice is that these sensors, because they are infrared, are quite sensitive to artificial lighting that you may have installed on your layout. There is always some infrared emitted from lighting such as this, and it can interfere with things. So if you put all this together and you find once you're on the layout your signal's always showing red no matter what you do, have a look and see if you've got a light pointing at it, or there is a light source that could be interfering with it. Turn that light off and then see if it starts working. If it does, what you'll need to do is just play around with the angles and the sort of positions of those LEDs. I drill the holes slightly too big so I can bend them and move them around a little bit if I need to, just to get the final tweaking done. But under normal circumstances that won't be an issue. It's only really if they're directly under a light source that tends to be a problem. So I'll just quickly do a test to show you that it does actually work after all of this. So we'll be running underneath the 3 aspect signal, and it won't trip until the middle of the locomotive passes over that sensor. There you go. And the final test here, we see that the signal is showing a yellow aspect, and obviously a train is allowed to proceed when yellow is showing. And we can see it trips back to red straight away. So on that note, I will call the project a success. And if you haven't already worked it out, because this is an infrared system, the signals will continue to operate as they should when you're running the layout in the dark. So there you go. Hope you found this video helpful. I know it was quite a long one. If you're still with me, I thank you for watching the whole thing. I put quite a lot of effort into this video, and it has taken me ages to get it all filmed and edited together, but hopefully from what you've seen you can take something away from it. It's a fantastic little project. I really enjoy doing all of this. The only thing I don't like is soldering it all together. It does require quite a lot of soldering, but the actual design of the circuit, understanding how it works and putting it in situ on the layout once you've got all the components together is quite rewarding, and I think you'll agree that the overall effect looks pretty good. So hopefully you understood some of it, or even better all of it, and I'll be back soon with another video.